Alright, welcome back to another Algebra 1 state test review video. Today we're talking about standard F.LE.3. Let's jump right in. Question 1. Functions f of x and g of x are given. F of x is equal to 2 to the x, g of x is equal to 2x. Which statement about f of x and g of x is true? F of x is greater than g of x for all values of x. G of x is greater than f of x for all values of x. F of x is greater than g of x for all values of x where x is greater than 2, or g of x is greater than x of x for all values of x where x is greater than 2. So let's put in our two equations. F of x equals 2 to the x, as well as g of x is equal to 2x. Okay? And let's see what we got here. First off, if you zoom in a lot, you can see that at this point, f of x is greater until you get to here at x equals 1, at which point 2x becomes greater until you get to here at x equals 2. And then once you hit x equals 2, f of x will always be bigger. So we know that there is a brief moment in time where g of x is greater, so we can eliminate choices A and B because that says for all. So now we're looking at purely after x is greater than 2. Well, after x is greater than 2, the black line is always above the red line. It's always, always, always higher, so it's always going to be greater. So that would mean that f of x is always greater than g of x for all values of x where x is greater than 2. Question 2 is going to be solved via the same method. Two functions are given. Let's put in our two functions. F of x equals 1.5 to the x. And g of x equals x squared plus 4x plus 1. Let's zoom in. Okay? So what do our choices say? For all values of x, f of x is less than g of x. For all values of x, f of x is greater than g of x. As x approaches positive infinity, f of x is less than g of x. As x approaches positive infinity, f of x is greater than g of x. Okay. So, as you can see, once again, there is a situation where f of x is greater than g of x. It is right here in between these two dots. F of x is larger. So you can get rid of all values of g of x. So now let's talk about what as x approaches positive infinity means. What as x approaches positive infinity means is that as you get further and further up, okay, as x gets further and further to the right, going on forever and ever and ever, okay? Excuse me one second. Okay, so yes, we're at the point where g of x is greater than f of x. However, if you scroll out a little bit and you keep going, you'll see that they do eventually cross again at 13. And then f of x takes over. And this is expected. And the reason that this is expected is because this has a higher exponential base. Okay? So when you have a situation where you have an exponential function versus a quadratic function, as x gets higher and higher, there will eventually come a point like this where the exponential function of 1.5 to the x just completely pulls away from a quadratic function. Okay? So what I don't want you to do is just immediately go to zoom out a bit and be like, oh, hey, look at that, from only go out to 10 and see that, oh, yep, g of x is still in the lead. All right, that's enough. Zoom out more. Because if they're telling you that as it approaches infinity, we're talking about big, 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 big numbers. Okay? So zoom out more, or, like I said, know that an exponential function like this will almost always beat a quadratic function, if not always. Eventually. So it is as x approaches infinity, f of x is greater than g of x. Alright, so that's going to do it for this video. If you have any questions, feel free to let me know. Otherwise, good luck on your state test.